Hey everyone, I'm back with another calculus lesson, and today we are going to learn to sketch a curve. I have a graph here. We have a function. We need to sketch f of x is equal to x divided by x squared minus 4. And below here are the 6 general steps we take before we can sketch the curve. They're intercepts, domain and range, asymptotes and behavior, increase and decrease of critical points, concavity and inflection points, and the actual sketching of the curve or graph. Now, you don't need to memorize this. I'll put it in the description on an exam anyways. I think they'll give you these. I'd be surprised if they made you memorize this, honestly. So let's just get started. Okay, first we will be doing our intercepts. For the x-intercepts, it's wherever f of x is 0. It's just at x equals 0. That's the only one. Now, y-intercepts, f of 0 is 0. So y equals 0. There's only one intercept, and it's at the origin, 0, 0. Okay, now on to part B. Domain and range. As far as the range goes, it seems to be from negative infinity to infinity because I don't see any restrictions. There's no outward restrictions saying where y can't be and such, not at all. So yeah, it's just negative infinity to infinity. Domain. It's anywhere where the denominator is not 0. X squared. And x obviously cannot be plus or minus 2. So domain would be like this. Now for the part C, asymptotes. VA will stand for vertical asymptotes. We just solved it in part 2. X can't be negative 2 and 2, right? So those are where the vertical asymptotes are. And HA, horizontal asymptote, it's where x is plus or minus infinity. So lim well, I mean, x squared at infinity, x squared is way, way larger than x. So it's pretty clear that 0. So there's only one horizontal asymptote. It's at y equals 0. Now let's take a look at the behavior of the graph as it approaches each component of the asymptote. Behavior will be down here. Okay, so let's take a look at the horizontal asymptotes first. So let's see from negative infinity first. Now, as x becomes a very large negative number, this would be positive. This is negative. It's 0, so the answer is going to be 0, but it will be a very, very small negative number. So that's used to indicate that 0 negative. Lim x. What about positive infinity? Well, it's just going to be 0 plus a slightly positive number. Slightly. Okay, how about the vertical asymptotes? What happens if you approach the left side of x equals -2? So let's think. This would be a very, very, very small positive number. That's, yeah, negative infinity. Let's do this for the other sides. What happens if x were to equal -1.99999? Okay, so this would be -1.99999. This would be a very small negative number. That means that approaching this limit, it's equal to infinity. And you can just honestly experiment with this. I've already done it, so I'm just writing this in. But like if as you approach each vertical asymptote, just get as close to the number in question as possible to see if it's positive or negative infinity. That's the way you do it. Get a calculator or use your head or something. It takes practice, honestly. It equals positive infinity. Yeah. So I'll give you guys, this might be a lot to take in, so I'll give you guys a second to process all this before I move on. So the intercepts, pretty straightforward. The range and domain, pretty straightforward. How I found the asymptotes, it's not that bad. Take a look at the behavior. So now you know that as the function, as x is negative infinity, it's a number, it's just barely beneath the y-axis, the x-axis, sorry. As it approaches infinity, it's just slightly above the x-axis, when you approach -2 from the left-hand side, the number will become very negative. As you approach -2 from the right-hand side, it'll become very positive. As you approach 2 from the left-hand side, it will be very negative. And as you approach 2 from the right-hand side, the function will be very positive, very high infinity. So that's good. So far, so good. Let's erase this. Take a second to jot this down or whatever, but I'm erasing it now. Okay, part 4 of 6. We're going to find the increase and decrease of the function and the critical points. So let's find f prime. Let's find the derivative of this first of all. F prime x is equal to, so f prime x squared minus 4. If you don't know how to find the derivative of something being divided by something, shoot me an email or look through your textbook and review this section. X times 2x over x squared minus 4 squared. And this is, let's see, x squared minus 4 minus 2x squared is negative x squared minus 4. Now, the critical points, there are none. There's no place where negative x squared minus 4 equals 0 has a real solution. Crit PT, I'm just gonna, that's the short name for it. There's none. Now, by analytics, okay, so negative x squared minus 4 is always going to be negative. You can put any number in there and it's always going to be negative. X squared minus 4 squared will always be non-negative. So it looks to me that f prime x is always negative throughout the domain. So by analytics, we can say function is constantly decreasing throughout its domain. Throughout the domain. D is short for domain, and I wrote the domain earlier on in this video. Yeah. So on to part 5 of 6. I'll take a second to jot this down, maybe pause the video or something. I don't know. Concavity and inflection points. Okay, so in the last part, I remember this. I said f prime x is equal to negative x squared minus 4 over x squared minus 4 squared. Okay, so let's find the second derivative first before we do anything else. I'm going to be quiet for this part. Now, people are probably wondering, why can't I just speed this part up? It's actually good learning for me, as I'm still a student, and it's nice to have a refresher on these once in a while. Besides, my editing skills aren't that great, so yeah. Let's see, so times the derivative of x squared minus 4 squared 2 x minus 4 dot 2x. Yep. Yep, I'm happy with that. And then that squared is to the power of 4. Now, obviously, this is too ugly. Let's simplify this a bit. Negative 2x times x squared minus 4. I'm just simplifying, factoring out x squared minus 4 on all sides of the equation. Plus x times 4x. I already factored. Sorry, wait, did I make a mistake somewhere? Sorry, it's x squared plus 4. Yeah. Okay. Yeah, because this was canceled. Okay. And that's all divided by x squared minus 4 to the power of 3. Okay, keep on going like this. Negative 2x cubed. Yeah, negative 2x cubed plus 8x. Plus 4x cubed plus 16x. Which is equal to 2x cubed plus 24x over which also equals 2x squared plus 12. There we go. Yeah, so the second derivative, f prime prime x equals 2x x squared plus 12 over x squared minus 4 cubed. I'm just going to erase how I found the second derivative here. It's also a good practice for you to, if you're shaky on your finding the derivatives with the division rule, then this is a great opportunity for you to practice. Okay, so now we found that say, okay, so where does, first of all, let's do the easy stuff. Where does f prime prime x equal 0? That's pretty easy. It's at the origin. Okay, and this isn't a definite inflection point, but it's a candidate inflection point. Now we have to find out where the second derivative is positive and negative to determine concavity. Now, for a review, concavity is basically describes the shape of a curve. I generally like to think of concave up and concave down in something like this. Like concave up looks something like this. It's like a nice curve. The water is inside a cup. And concave down is very bad because the water will leak out. So like that's the way concavity just describes the shape of the curve, in case you're wondering. So yeah, let's do some drawing. So the domain, okay, from negative infinity to -2, because that's where an asymptote is. From -2 to 0. From 0 to 2. Asymptotes aren't inflection points, by the way, guys. Like the inflection might change, but you don't call them inflection points. Call them inflection sticks or whatever. I don't know. So these are possible places where the concavity of the function might change. So let's so this is f prime x. So let's take a look at 2x x squared plus 12. I simplified it as much as possible so I could do this part. And 2x Okay, so let's get to it. X squared plus 12 is always going to be positive, so let's just focus on the 2x. Negative infinity, this will be negative. From 0 to infinity, it's always going to be positive. Piece of cake. Okay, x squared minus, let's just focus on x squared minus 4. X squared minus 4 squared will always be non-negative. So I know it's going to be positive here and here. I'm thinking of the parabola x squared minus 4. And will be negative here and here. Now divide. Negative divided by positive is going to be negative. Negative by negative is going to be positive. Positive divided by negative is going to be negative. And positive divided by positive is obviously positive. So here we have our answer. What does this tell us? So it tells us where f prime prime x is negative and positive throughout the domain. And based on this information where it's negative, so f prime x where it's negative is concave down. I'm going to write CD or concave down at negative infinity, -2. And 0 to 2. And concave up, CU. And 2 to infinity. And since the inflection, the concavity changed at 0. Yeah, it changed. Did it change at 0? Yeah, it seemed to have changed at 0. Yeah, so that means there is an inflection point. I'm going to write IP, short for inflection point, at x equals 0. We now have all the information that we need to sketch the graph. I'm not going to sketch it. I'm too lazy to do that. So I just put the function into a graphing calculator and look at all the characteristics that we've solved throughout this long period of time. So there's only one origin here at 0, 0. We see it's decreasing throughout its entire domain. The function is decreasing. And yeah, there's the concavity, the points. It's here like it's concave down from negative infinity to -2, and from 0 to 2, and it's concave up from 0 to 2 and 2 to infinity. And look at the behavior of the function as it approaches each asymptote. See, just below the x-axis, just above the x-axis here, like very negative as you approach -2 from behind. Everything we solved, it's all shown in this graph. So that concludes this question. If you have any other wait, sorry, I forgot that. Yeah, so sorry. Yeah, so I was saying like all the characteristics, the featured characteristics we see are shown on this graph right here. So that concludes this video. If you have any other questions, please don't hesitate to email me and such. But for now, I gotta jump. I'll see you guys on the other side of the bridge. Catch you next time.